Hello guys, welcome back to Data Science with Ruben. Today I'm going to be showing you how to do stock prediction using reinforcement learning. More specifically, I'm going to show you how you can use reinforcement learning to train a model to tell you whether you should buy, sell, or hold a stock. Okay, so just as a disclaimer, do not use this to actually try to make money in the stock market, okay? The stock market is incredibly complicated, and this code does not take that into account. It's a simplified version intended for beginners to teach them how to use OpenAI Gym and reinforcement learning and get started, right, with stock prediction. So let's get started. So to start out, we have some things that we need to import at the top here. And this code, by the way, will all be in my GitHub. So, and I'll have a link to that in the description of this YouTube video. So you can click that if you want to refer to the code that way. But yeah, import, we need pandas, NumPy, Gym, stable baselines 3. All right, then whenever you're working with OpenAI Gym, you need to specify your environment. In this case, we're making a stock trading environment. So that's what I call it. And you always need to inherit from gym.env, which is OpenAI Gym's environment class. Then in our constructor here, we need to call the parent class's constructor. Don't worry about that if you don't know what that means, but all you got to do is copy and paste this line and change this to whatever the name of your class is. And then you're good. You're going to set self.df. You're going to set that to be equal to the df parameter that was passed in. The df parameter is your data set. So this is the data set we're working with, okay? And basically each row here represents a day of trading for a stock. So the first row is, you have the date, you have when the opening price, the high price, the lowest price, the closing price, as well as the volume, right, for each day. So that's the data set that we are working with, and that gets passed into here and set as a member variable so that we can utilize it other places in the class. Next, we have two very important things here. So we have the action space and the observation space. The action space specifies so your actions that you can possibly take. So in this case, we have 3 actions: hold, buy, and sell. Those are our 3 actions. So hold is 0, buy is 1, and 2 is sell. So there's 3 actions, and the observation space is a box, and it's of length 5, one dimension of length 5, from 0 to infinity. The values are 0 to infinity, and you might be like, Ruben, what the heck are you talking about? And what I mean is, if you look at the data here that I just showed you, it's everything except for this first column, because we're actually going to remove this first column because it's not a number, right? And it's going to cause problems in our code because of that. So because of that and the fact that we never use it, we just remove it. So it's going to be these 5 numbers. So that's why it's 5 here. It's one dimension of length 5. And if you look here, every number is between 0 and infinity. So that's why we specify that range here. And so that's our observation space, because this would be an example of one observation, right? The thing I have highlighted right here. Okay, so now we have a very important method here, the step method. And this method is used for training, and you're going to get passed in, you're going to get an action. Now this action is what the model thinks you should do based on your observation. So it might be buy, okay? So let's say that the current step that we're on, our current observation is this first row, okay? Because I'm going to run through an example for you guys to make it like clear for you. And let's say that our current observation is this, okay? So basically, and let's say that our action is to buy, okay? So action is 1, which means buy, okay? Now, the first thing we do is calculate the next step. What the next step is the next row in our data. So it's this row here, okay? So that's what next step is. It's a number, which is the index of the row, right? So in this case, it's referring to this row, the next row. So we are buying, right? So we're doing this code block here that I have highlighted. So what this is going to do here is it's going to go into our data to the next step, which is, remember, the next row. It's going to grab that closing price, so this number that I highlighted here, and it's going to, so that's 158 point something, and it's going to do that minus the current rows, the current observations row, which is this one, and it's going to get the closing price, which is 160 something, okay? And it's going to, so it's doing 158 minus 160, which is going to be a negative number, right? And that makes sense here, right? Because if you think about it, what this means is that we bought it at 160, and now it's going to become lower. It's going to go down to 158. So we bought it at a higher price and it went down. That's bad, right? You want to buy cheap. So this is going to be negative. So that means that's good, right? We've programmed this well, because in that case we want it to be negative. So so now we have a negative reward. Now we need to specify whether we are done or not. We need to figure out, are we done? And what that means is in this context, we want to be done when this is our current row and this is our next row. So when the current step is this row and next step is this row. That's what, when we're on that step, we're done. After that, we're done, okay? Because what would happen if we didn't stop, this would be that this would become the current step, and then we have a problem, right? Because we don't have a next step. So let's say our action was to buy again. We don't know if the stock is going to go up or down, right? We can't give a reward for buying at this step I have highlighted, because we don't know if the price is going to go up or down. So we can't do that, right? We don't have future data, so we can't. So the last one has to be where this is the current step and this is the next step. Okay, so that's what we determine here. Are we at the last? Are we done? Are we done now, right? And in this case, obviously, we're not done. This is going to be false, because we're only on the first row, and this is the next row, right? Current step is this first row. Next step is this row, right? So we're obviously not done. Done is going to be false. Then what we do is we increment current steps. So current step becomes next step. So it becomes the same value as next step. And then we get the next step, which is this one, right? And we set that to observation, OBS. Now, you always have to return the next observation. That's going to be the first value returned by the step function is the next observation. So remember, the current observation for this call to the step function was this row, right? So that means that we have to return the next observation, which would be the next row, this row. So that's why we're returning that. We return the reward we computed. We return whether or not we're done, and yeah. And just to give a quick, more like in-depth explanation of this part, because I know it's a little complicated, let me do that. So for holding this first part, the agent does not interact with the market in that case, right? It neither buys nor sells. If the agent chooses to hold, it gets a fixed reward of 0.5. This could be seen as a small encouragement for the agent to not make unnecessary trades, thereby minimizing transaction costs in a real-world scenario. So the next action is to buy, and in this case, the agent buys a stock, right? Obviously. The reward is computed as the difference in the closing price of the stock between the next step and the current step. The agent benefits if the stock price rises, as it can buy now and sell later at a higher price. The reward will be positive if the closing price at the next step is higher than the current step, and it will be negative if the price decreases. Lastly, for sell, this is obviously where the agent sells a stock. The reward is computed as the difference in the closing price of the stock between the current step and the next step. The agent benefits if the stock price decreases, as it can sell now and buy later at a lower price. The reward will be positive if the closing price at the current step is higher than the next step, and it will be negative if the price increases. Okay, so next, the reset method here. This is all it's going to do is reset the current step to be 0. So going back to this first row here, right? And then this will actually get that first row. So it gets that. This is 0, right? So it goes and it gets this first row here. It gets the numbers in that first row, not including the first because we've removed that, not including this first column because we've removed that. So it returns those numbers there. The first row. Okay, so we got through that. Now there's just a little more I'm going to explain. So now what we're going to do is read in our CSV data, our data set. Okay, so this is, like I said, this is the CSV data. Now we're going to read that in using pandas. We say pd.readCSV. We pass in that data set, and just an FYI here. This data set here has to be in the same folder as this CSV file has to be in the same folder as this Python script, or this will not work, okay? Alternatively, you could specify the full path to the CSV file here, okay? But I think it's easier just to have them in the same folder and do it this way. Just specify the name of the file. That's just so you know. Next, you're going to have to sort the values by date. And so since we're working with time series data, right, this is time series, it's very important. And like I said in here, like we rely on like having the next step, right, the next day. So it's very important our data is in order. And this just helps to ensure that. In my data, it's already ordered like that, so you don't technically need this line for my data, but this, you might work with other data sets, right? And this just helps to ensure that it's in chronological order. And next up, we are going to drop the date columns like I've been saying, because they're not a number and they're not numbers, and that's going to cause problems in our code. And we never use it anyways, so just get rid of it. Okay. Then we're going to create a stock trading environment object using the class, right? And we pass in our data set that we read in, and that's going to become self.df, and that's going to be utilized throughout the class. Okay, so what this line does is you specify the reinforcement learning algorithm that you want to use. This is a Stable Baselines 3 algorithm. There's many of them that you can choose from. And here is I'm going to put this link in the description of this video, but this shows, depending on your action space, there's certain algorithms you can use and other ones you can't. And this table will show you which ones you're allowed to use. So in our case, my action space, let me go back to my code. So my action space is discrete, right? As you can see here, spaces.discrete. So that means I fit under this column here. So I can use any of these algorithms that have check marks in them. Okay? So in this case, right, in my code, I'm using A2C. I'm allowed to use that because I have a discrete, right? But for example, I could not use DTPG because there's an X there. So when you're playing around with different algorithms, trying to see which one works best for you, go to this chart and try the ones with check marks in them, okay? And that's a hyperparameter you can play with, the algorithm, right? You can change A to C to something else and see if that works better. That's your job, to play with this code and that'll help you get familiar with it. Try to change hyperparameters. Hyperparameters, for those who aren't familiar with machine learning, are just like knobs you can tweak in your model to make it train better, right? So for example, you could change this algorithm. That's a hyperparameter. You can change the number of time steps that you're training for. That's another hyperparameter, right? So play around with this and try to get something that trains best. Anyways, so we're using A2C. This next one, it's a little advanced. So basically what this is you don't need to worry about it though, but you're basically telling it what you want to use for your policy network. In this case, we're saying MLP, which stands for multi-layer perceptron, and that just means the simplest kind of neural network that exists. Okay, that's all that. It's just a fancy word for a regular simple neural network, regular neural network. Okay. Then we pass in our environment object, our stock trading environment object, and we say verbose equals 1. Verbose equals 1 means that we want our model to output information about its training. So when it gets trained, it's going to output information, and I'll show you how to read this in a second. And then we want to train the model for 10,000 time steps. And like I said, this is a hyperparameter you can play with to see. You can train it for longer or shorter, figure out what works best. Okay, so now we've trained our model. Great, okay. But now I want to give it some unseen data and see if it can tell me whether I should buy, sell, or hold. So this is 1 day, right, of trading, and I want to give it this information, right, this closing price, and I want it to tell me whether to buy, sell, or hold. So what I do is I create a new data frame with only one row this day, and I'm going to create a new environment, a new stock trading environment object using that data, the new data. And I create that environment and I reset it, right? I call the reset method, which, like I said earlier, will set the current step to the first, to this row, right? It'll set it to this row and return, and then it will actually return these numbers, right? The first row. So that's what it returns here. Yeah, observation. Okay. Then it takes that observation, which is this row here, and it puts that into our model, and our model will tell us, based on looking at that, whether we should buy, sell, or hold. And that's what it returns here. So it'll return either a 0 or 1 or 2 for whether it thinks we should buy, sell, or hold based on this information that we gave it. Okay, and then I just have an action dictionary here, which will convert the number to something a human can actually read. So like, let's say that the model says you should buy, which is a number, which is 1, right? Then I actually convert that to be the word buy. Okay, and that's what I do here using the action dictionary. Okay, so hopefully that made sense to you. Now I'm going to be describing how to interpret this output here when you train your model, okay? So when you train your model with verbose set to 1, right? When verbose here is set to 1, it outputs a table with various performance metrics at regular intervals during training. Let's explain what each of these metrics mean, okay? So rollout episode length mean and rollout episode reward mean are the average length and reward of the episodes respectively. A higher average reward per episode generally means the model is doing well. Time FPS is the number of iterations the model is able to compute per second. This is mostly dependent on your hardware and doesn't tell you much about the performance of the model, okay? Then you have time iterations, you have time elapsed, and then you have total time steps. And these show you the total number of iterations, the total time elapsed, and the total number of time steps so far, respectively, okay? Next, you have train/entropy loss, and that is the entropy loss of the model. This is a measure of how uncertain the model is about its actions. Typically, we'd like this to decrease over time, which would signify that the model is becoming more confident in its actions. Then you have train explained variance, and that is a measure of how well our model's predictions explain the rewards it's seeing. If this is 0, it means the model's predictions are no better than just predicting the mean reward every time. If this is 1, it means the model's predictions perfectly explain the rewards. We'd like this number to increase over time. Okay, a couple more. So train learning rate. Train/learning rate is the learning rate of the model's optimizer. In most cases, this will stay constant unless you're using a learning rate schedule. Then we have train and updates is the number of times the model's parameters have been updated. Train/policy loss and train/value loss are the losses of the policy and value networks respectively. And we'd like these to decrease over time, okay? So by observing these metrics throughout the training process, you can get a good idea of how well the model is learning to trade stocks. Okay, and that's it. So hopefully this video has helped you. I'm going to, I think for my next video, maybe I'll make a video where we actually will define our own neural network architecture and kind of make a little more complex version of this code, maybe. So stay tuned for that if you're interested. But yeah, thank you for watching. Please subscribe. It takes me a lot of effort to make these videos, and I love to make these for you guys. So I would appreciate if you could show your appreciation by giving me a like on this video and subscribing. That would be really awesome. So thank you so much. Bye.